Good afternoon, everyone. I think we'll get started because it looks like we're just 1 minute past 2. So welcome to this webinar series for the Northeast Coastal Acidification Network, also known as NECAN. NECAN is part of the Northeast Regional Coastal Ocean Observing System, also known as NERACOOS. My name is Kelly Canacey, and I'm a program coordinator for NERACOOS and NECAN. For those of you who are new to this group, NECAN is a regional nexus of stakeholders who are affected by or working on ocean acidification. And it's a group that brings together scientists, resource managers, policymakers, educators, and other stakeholders who are coordinating efforts in regional observing, research, modeling, and many other activities. NECAN also provides an opportunity for multidisciplinary interactions among stakeholder groups, which ultimately helps build towards a better informed community working to respond to and address ocean and coastal acidification. NECAN's activities are guided by several working groups, including a steering committee that meets on a monthly basis, and NECAN also has a science, industry, policy, and education working group. You can learn more by visiting the NECAN website, which I will pull up in just a second. So you can visit necan.org to learn more. And you can also learn more about the NECAN webinar series by clicking this green tab in the upper right-hand corner that says NECAN Resources. And that will take you to a list of the webinar series. We're currently in the second NECAN webinar series. So if you click this link, you'll soon be able to access a recording of today's webinar, and you can also access recordings of previous webinars as well. NECAN hosts these webinars on a periodic basis on a variety of topics related to OCA. They're free and open to the public and obviously accessible via our website. One last thing I'd like to share before we get into the webinar today is a website that many of you have probably heard of before. It's the Ocean Acidification Information Exchange, which is a new collaborative website designed to foster interaction and discussion among people who are working on ocean and coastal acidification. In order to join the site, you have to request access, which you can do so right here on the home page. And once you do have access, you can join the conversation here on the member side. And we actually have a brand new team that I can direct you to, a data management team. And that might be a really good place to go after this webinar if you have questions that weren't answered or if you want to keep that conversation going with our speaker and your peers. So with that being said, let's turn to today's presentation. And just briefly before we get into the talk, if you're new to the GoToWebinar software, you might have already noticed that you are muted as an attendee. And we do encourage you to ask questions, and we have about 10 to 15 minutes saved at the end of the webinar where we can address your questions. So the way that you can ask your question is by typing it into the question box, and then I can read your question aloud and our speaker can answer. You can also, if you'd like, use the hand raise function. And if I see that you have your hand raised, then I can actually unmute you, and that way you can ask your question out loud. Just a note of caution, using the audio in GoToWebinar tends to work best if you're on your phone or if you're using a headset. That just reduces some of the feedback noise. So keep that in mind, but you can use either typing into the question box or raising your hand to ask your question aloud if you would like to ask a question at the end. Finally, let's meet our speaker for today. So today's speaker is Liqing Jiang. Liqing is an associate research scientist at the University of Maryland, and he works at NOAA's National Centers for Environmental Information through a cooperative institute agreement with the university. Liqing is a chemical oceanographer who specializes in the study of inorganic carbon cycling and ocean acidification in the global and coastal oceans. Liqing received his PhD in oceanography from the University of Georgia in 2009 and went on to do postdoctoral research at Yale University. He's been with NCEI since 2011, and one of the main projects he's working on, which we'll also hear about today, is the Ocean Acidification Data Stewardship Project, and that's funded by NOAA's OAP, or Ocean Acidification Program. In addition to data management, Liqing spends a lot of his time on global synthesis projects. So I will quickly turn it over to Liqing and take it away.
All right, thank you, Kelly, for the introduction. I also want to thank Kelly and Dwight for the invitation, which makes this possible. Good afternoon, everyone. My name is Liqing Jiang. Today, I'm going to show you the Ocean Acidification Data Management efforts at NOAA's National Centers for Environmental Information. Here's an outline of my talk. First, I'm going to show you the Ocean Acidification Data Stewardship Project. After that, I will show the OADS project, which is the replacement for the former CDAC. After that, I will talk very briefly about NOAA's public access for research results requirements. Towards the end, I will show some of the results from our global synthesis efforts. By the way, if you have questions in the middle of the talk, feel free to interrupt me. When NOAA's Ocean Acidification Program was first formed, Libby had emphasized the importance of data management. She worked with CRISA at NCEI to transfer some funding to NCEI. NCEI also contributed some base funding towards it. So we were able to form this Ocean Acidification Data Stewardship Project at NCEI. The primary mission is to manage data that are generated from the OAP-funded projects and help the OAP PIs meet their data management requirements. Right now, I'm the lead PI, and I'm the person who is doing most of the work. Ross Parsons at NCEI, he's my federal manager. In the future, it's likely I will work more closely with Scott Cross. He's now my new immediate supervisor. We are located in Silver Spring at NOAA's headquarters, and here is our website. OADS manages a full spectrum of OA data sets. This includes chemistry data collected from a surface underway cruise, or CDD profiles, or time series moorings. We also manage, actually about half of our data sets are biological. A lot of them are laboratory experiment data, and we already archived many model output data as well. How to manage all of these different types of OA data sets efficiently in a cost-effective way has been one of our major challenges with this project. These are NCEI's data management components. Before I go into the OS components, let me first show the NCEI ones. Despite all the issues we had in the past, I believe NCEI has some of the best technical infrastructures of any data management entity, period. These include our long-term archive system, the version control, stable data citation, infrastructure for control of vocabularies, and our NCEI's landing page. In the following slides, I will show you more details about each of these components. The long-term archive system is really the pro jewelry of NCEI's data management system. Here is the safest place to store your data, period. In paper, we always say that we guarantee the data will be accessible for 75 years, but in reality, our goal is to make sure your data will be available forever. For example, we have backup in Maryland, West Virginia, Colorado. Even if there's, in the worst case scenario, there's a natural disaster wipe out the entire NOAA building, your data will still be safe. And even if some hacker was smart enough to hack into all these systems, which is highly impossible, we still have offline copies in tapes. And we drive it, every day somebody will get a copy of the backup and drive a van and take the tapes to somewhere else. Version control. Here at NCEI, the publication of a data set is actually very much like publication of a paper in a science journal. Once it's published, there's no way you can make changes to that specific version. It's going to be available forever. You can request to create a new version, but all the historical versions will continue to be available. Data citations. Here I want to mention two things. The first is about the DOI. I think there are too many misconceptions. People think that by having a DOI, their data citation will be valid forever, which is not really true. Your DOI is good until the link it's working on is becoming invalid. DOI really only manages a link. What's really important for a data citation is to make sure the data resides in a long-term archive. That's the only way to make sure data citation will be valid forever into the future. The second thing I want to mention about the citation is that NCEI, we actually allow you to cite a specific version of your data sets. This is very important. For example, you can download a version of the data sets, do lots of synthesis. In the future, people could create a new version and make lots of changes. It's very important you are able to cite that specific version. Control vocabularies. These are basically a list of uniform terms so that we are going to make data discovery possible. I can give you some examples. For example, if the PI sends me a dissolved inorganic carbon data and they call it a DIC, and the second person sends me a very similar data, but they call it a total carbon, I think we have a third person call it a total CO2, and things like that. If you just archive those metadata as is, in the future, when it comes to data discovery and people want to search for dissolved inorganic carbon, they can only find a fraction of data sets. That's not good at all. That's the reason we maintain control of vocabulary for many terms, including the variable observation type, instruments, and all this stuff. Landing page. Here are the NCEI's landing page. We manage many different types of data. So this page is really not catered to one specific project. Only has the basic information like the title, abstract, citation, the spatial temporal constraint, and then some keywords. I think there are two issues with this page. First is there are some information, things like this ancillary information. I'm not really trying to say they are not useful. They are, but the thing is that if a scientist come here to look at the scientific content or a data set, they probably care this less. And we don't want to use this information to bury the really useful information they are interested in. And in terms of the really useful information the scientists are interested in, I think the problem with this page is does not document as much rich information as they would want. I think scientists would want their meta page to be something like this. Only the information they are very interested in about the scientific content of their data. At the same time, for this information, we provide really, really rich information for them. For example, in this example, this is for one variable alone, dissolved inorganic carbon, and we have all this ancillary information. Make it very easy to do future quality control or synthesis effort in the future. So to build the page, I just showed you in the last slide, we had to work with the scientists. This includes the NOAA scientists as well as the scientists from the external community. We work together to make sure the list of terms we manage are really the thing they are most interested in. We call it a metadata content template. The template includes all these components. Here I just want to show you one example of one component. For example, for each variable, we will document this variable abbreviation. Usually this is the column header names in the data files. And sometimes if we only provide the abbreviations, people do not know their full names, and we also need to make sure it's units there, how it's being measured, whether it's in situ data or manipulated data, etc. This template is really the most important thing about this project. And I also want to say that one very good part about this template is that it can be applied to most of the major OADS sets we handle every day. So this is very important for our project because it's very important for us to do things in a cost-effective way. Yeah, this is really the most important slide of my entire talk this afternoon. These are the OADS data management components. There are really two components. First, let's look at this red column. We try to leverage the best technical infrastructure at NCEI. This includes the long-term archive system, version control, stable citation, control vocabularies. The reason we are doing this is because we need to make sure we are going to make the feds happy. We're going to make sure everything we do here is compliant to all the laws and regulations from the federal government. That's very important for sure, and that's something NCEI excels. At the same time, we build this OADS rich metadata management system to make the scientists happy. Remember, I just showed you the metadata accounting standard. We built that standard by listening, by talking to all the scientists in the field. So we are trying to get the best of both worlds. We trying to make the feds happy. We're trying to make the scientists happy as well. I believe this is why this project has been a success over the last 6 years. So based on the metadata accounting standard I just showed you over the last several slides, we created this metadata records standard. We call it XML convention. And then out of that, we display our information in a very user-friendly format in HTML. I already showed you the format. In the following slides, I'm going to show you the summation interface and discovery interface. Any questions so far?
Nope, it doesn't look like we have any questions.
Sounds good. Yeah, so here's the OA part. I think we should have time for me to give you a demo for this. Let me just click on that. Oh gosh. We basically allow you to do a data discovery based on something really based on the variables, parameters, observation category, the temporal coverage and spatial coverage, and we allow you to do that in a very user-friendly format. For example, if you go to NCEI, you want to do some search, you need to know some search syntax, how to use and or use parentheses, things like that. But here, everyone can do that. Just click on checkboxes. For example, just use this one example. You can also use here is actually autocomplete. For example, if you choose all the DIC from here, it's equivalent to click the checkbox here. It's really easy to use. And for example, I would only want the DIC and alkalinity collected from CTD profile. I would only want data sets after the year 2000. And then, for example, let's see how many data sets we can find. That's 36, for example. And for example, if you are only interested in a specific region, you just click, hold Shift, cross. Let's use the Gulf of Mexico as an example, because that's the place with probably with the least data sets in terms of DIC and alkalinity. Oh, actually, it's not that bad. And you can further refine. This is actually a very powerful field. You can put anything here. This could be, for example, if you can search for all the data sets related to a research vessel or a person. I'm going to just put one over here. Know that we have 4 data sets from a RICS group with this kind of data. All right. If you don't have questions, I will go back to the presentation. Okay, now let's look at the summation mechanism. Yeah, this is our interim solution for summation. It's not something really high tech. It's based on Excel, but I do not recommend you to underestimate this, because Excel does has its advantages. You can, for example, you can bring this your computer to a research vessel without worrying about internet connection. You just input information in Excel and click save, and then you are done. And you can just open the file later on and put on more information there. When you are done, you can duplicate your copy and create a new summation by just modifying very few fields. So it's actually very easy to use for some people. Once I receive the metadata in Excel spreadsheet, I create a MATLAB program. I can extract all the information and dump them into our XML convention standard. Yeah, this is something very, very important to us as well. I want to thank OAP for the increase of funding for this funding cycle. So we are able to work with NOAA's PMEL in Seattle to build this scientific data integration system. For data producers, this is very important. It's going to make your data summation even easier. And for us, it's also very important because the goal is to automate a lot of these data archiving base level data management procedures, so that in the future, Alex Kozer and myself, we can be liberated from all those logistical steps, and so that we can focus more of our time in improving the scientific quality of these data sets, or focus ourselves on synthesis efforts, things like that. This is really, really important to us because we are very short-handed right now. In addition to the managed standards, we are also working on standards for data files slowly. Right now, we have data standards for in situ observational water chemistry data. This includes the data collected from a surface underway cruise, CTD profile, and mooring data. You can just click on the column header description or just download an example file. We already pre-filled all the column headers. Here, I just want to show an example. This is the column headers for discrete measurements of carbonated data collected from CTD measurement. The reason I'm bringing it here because this is a very, very new development. I worked with people from PMEL and AOML. This includes people like Dick Feely and Rick Wanninkoff to develop these column header standards. Remember, in the past, we rely on the WOS column header standards. The problem with that is very outdated. For example, they would for dissolved organic carbon, their abbreviation is DOC, but for DIC, their abbreviation is T-carbon, not CRBO and CRBN. And for alkalinity, they call it alkali, ALKLI. I think this makes a lot of people angry. That's the reason we are trying to modernize these standards, trying to standardize a lot of things. The next step is that we're going to send this out for external review, and hopefully we are going to publish technical standards out of this so that it can reach more people. That's everything for the OS project. Kelly, should I pause for questions or just continue?
We do have 2 questions. Maybe we can take those now.
Okay.
There's a question from Katie Goldsmith. How will the OADS compare to what the folks on the West Coast are planning to do with IPA COA?
Yeah, I'm not very familiar with the IPA stuff, actually.
Okay.
Yeah, sorry about that. Actually, what is the person who is asking the question's name? Would you please ask her to send me an email about this? I'm very interested in that. I want to learn more about that for sure.
Yeah, absolutely. I will connect you.
All right, thank you.
Great. And then the second question is from Joe Salisbury, who said, recently I've been asked if nonprofit groups can submit data. The data quality is not on the same level of the NOAA labs, but often the uncertainty is well characterized. Is the way that those nonprofit groups can submit their data?
Hi, Joe. That's a very good question. Right now, for the OS project, we only manage datasets that are funded by NOAA's Ocean Acidification program. I think that's something Dwight wants me to be focused on. We don't want to dilute our effort. But the good thing is that if your dataset is inorganic carbon dataset, feel free to send it to us because it's going to be processed. Right now, the OCAS project is here. It's going to be processed by Alex Kozer. For biological data, I'm not sure.
Okay, thank you.
Sure. All right, let me show the OCAS project. This is the replacement for the CDAC. Yeah, I'm sure probably most of the audience in this group are already very familiar with the CDAC. CDAC is a data analysis center located in Oak Ridge National Laboratory with the primary mission of managing inorganic ocean carbon data for the international community. It's been highly regarded by the international ocean carbon community. I have to say that personally I learned so much from CDAC. OS benefited a lot from all the CDX style data management. We're trying to learn the best of both worlds. Unfortunately, in 2016, DOE decided to pull their funding out to CDAC. It's been a very interesting timing because even if DOE do not pull their funding by sending your data to CDAC, you are not going to meet your data management requirements anymore in the future. So I think it's really a good thing for everyone. We transfer the data management from CDAC to NCEI. So the plan was to transfer, to replace, to build something new within NCEI to replace CDAC. We decided to call it OCAS, mainly because it's pronounceable and has the words both ocean and carbon. The mission is exactly the same as CDAC. Our goal is to hosting and providing access for ocean carbon data for the international community. I think one of the reasons the CDAC was so successful because they can put together everything into this one place. So we strongly recommend you to submit your inorganic ocean carbon data to NCEI's OCAS project, regardless of their funding sources at all. We are going to take everything you send us. The infrastructure is very similar to OS. We rely on NCEI's long-term archive with version control, etc. And we use the rich management system developed by OADS. This is very important because now we have the OADS project, we have the OCAS project. We want to make sure that no matter a PI goes to which project, once their data is published, it's going to be exactly the same. The summation interface right now is OCAS also rely on the Excel spreadsheet, and we are going to use the implement SDIS to OCAS as well. The OE port for the discovery, both the OS and OCAS share one same portal. It's not like they are similar; they are the same one. There is only one portal. This is also important because we need to make sure that no matter a data consumer comes to which project, they should be able to find all the ocean acidification data sets. Yeah, I feel very proud and very relieved that this is done. We transferred 2,500 CDAC data sets to NCEI. It took me 5 years. And we did this through an automated program, but I probably receive on average 10 emails for each of these data sets. I need to fix all of the issues manually to so that automation will work. Finally, we get everything to NCEI now, so it's a huge success. We also pull the information from the older CDAC metadata pages and render them in according to the new OS metadata standards. We transfer the DOI ownership from CDAC to NCEI. We also changed their landing page for the DOIs to NCEI's archive management system. This is very important because now CDAC is over, but a lot of people publish their papers with the data citation pointing to CDAC. We need to make sure those DOI will continue to be valid, and those DOIs, as well as export codes and all the CDAC dataset IDs, can still be used as search keywords to retrieve their datasets. This is very important. We did this to ensure continuation in terms of inorganic carbon data management for the international community. We also transferred all the CDAC web pages to NCEI and just change the header, footer. Some of them we did more work to those. This is not as simple as you would think as well, because we have probably 5,000 pages or 6,000. It's a lot of pages. So I really want everyone to consider OCAS as a CDAC 2.0. This is not CDAC 1.0. We did lots of improvement to CDAC. Both OCAS and CDAC manage rich metadata information, but our template is more modern, more inclusive, more simplistic, and most importantly, the new template is compatible with the rest of OADS management at NCEI. The biggest difference is how we store our files. Right now, as I mentioned earlier on, we store our datasets in a long-term archival system. So rest assured, your data will be safe now. But in the past, it's stored in a very informal FTP. So this is a huge improvement. Yeah, if you are a PI and just come here to look for the content of a dataset, you're probably not very interested in this page. But I'm sure everyone here would agree with me that it's very important we do everything legally. We need to make sure all the datasets meet the federal regulations and all the PIs are compliant with the NOAA's requirements, so that at the end of the day, we are rest assured everything is good. And this is the new OCAS webpage, and the link is very simple, so welcome to try it out. Yeah, by the way, we have a very easy to use navigation bar. If you want to discover some data, just click Access Data. If you want to submit data, click Submit Data. It's very foolproof to use. Any questions? All right, let me move on then.
Not at the moment.
Okay, thanks. I will cover this really quickly. This is the NOAA's PARR requirements. As you know, the Obama administration issued several executive orders in terms of the open data policy. As a response, NOAA issued the NOAA's plan, NOAA's public access to research results. We call it NOAA's PARR. And NOAA also revised its NOAA data sharing directive for grants and contracts. In the following two slides, I just want to show the really bare minimum information about these legal documents. So the scope is for environmental data. This includes not only all the in situ measurement data, but also model outpost data, laboratory experiment data, basically everything that's all digital. If your data is non-digital, for example, if you have some fossil or analog tape, they are exempt. Affected group, including the federal researchers, as well as the recipients or the federal funds. For federal researchers, this requirement is retroactive. For recipients or federal funds, they are not. If you want me to summarize the NOAA's PARR in one sentence, this is it. So every word here is very, very important. Sharing data means making data publicly accessible in a timely manner at no cost in a digital format that's machine readable, along with the metadata necessary to find and properly use the data. I want to emphasize that this is super important. Every word here is very important. Timely means no later than publication or a peer-reviewed article. The older time where scientists want to hold their data until after publishing their paper is over, or 2 years after the data are collected and verified, or 2 years after the original end date of the grant. And the best part is whichever is soonest. Yeah, don't be. Yeah, a lot of people feel like 2 years is a very short time, but actually that's good news for you, because we require 1 year for federal researchers. If you, for example, if our colleagues at the PMEL and AOML are collecting some data, they have to send the data to us within 1 year. So 2 years is actually a pretty good deal for you guys. Yeah, NOAA requires intramural data producers to submit their data to a NOAA National Data Center. Yeah, basically, yeah, they're trying to encourage you to use the NOAA's NCEI to archive your data. Any question for the PARR? All right, then let's move on to the last part of my presentation. This I just want to show some of our synthesis results. The two of the most important indicators of ocean acidification are calcium carbonate saturation states and pH. We published this paper in 2015. It's about the distribution of oregano saturation state. These are the surface results. I just want to show some figures. Don't worry too much about the details. And if you want to get a copy of the paper, just do a Google search. You can find it, and you can download it for free. Right now, we are working on the global surface ocean pH results. It's very interesting. It turns out that the pH distribution is entirely different. The red dots in this panel are the saturation state. Here you see as high as 4.0 in the equatorial region. And as we move towards the poles, it's drop slightly above 1. So there's a huge latitudinal gradient. The blue dots are the pH. As you can see, the pH is more or less the same from the equatorial region to the tropical region. They are controlled by very different mechanisms as well. The only thing they share in terms of control mechanism is probably how they are affected by the addition or removal of carbon dioxide. We plotted the saturation state against the pH. As you can see, they are essentially not related at all. These are the pH results in February, August. This is average. Actually, yeah, this figure is not as colorful as the previous one I showed. Actually, this is more advanced because this color scale can be read by people who are colorblind. We also estimated the pH in each month of the year by using the global Vern 2 data, the DIC alkalinity, and then we use the global PCO2 results from Takashi's database. And now we can calculate the pH each month of the year. We also use the sea surface temperature from the World Ocean Atlas, which also provides a global distribution of sea surface temperature at each month of the year. The distribution is very, very interesting. And actually, the seasonal change inside the gyre and in the upwelling zone are entirely different. Some of them are controlled by thermodynamics. Some of them are controlled by biology for sure. We also projected the surface ocean pH into from 2010 all the way to 2100. Right now, I only showed you until 2050 because I just want to show you some examples. What's revolutionary here is this is the first time we actually rely on the sea surface PCO2 increase results at every single point of the global ocean. In the past, people just assume the sea surface PCO2 increase at the same rate as atmospheric CO2 increase, which is roughly the case, but not really true because some regions, they are upwelling, they are not like the equatorial region, they are not really absorbing as much CO2 from as much of those from the North Atlantic Ocean, for sure. So what we did was to use the model results from GFDL's ESM2M results. We derived all those results. It's very interesting. The projected PCO2 in the surface ocean in 2100, the increase could be different by as much as 150 micro atmosphere. So that will cause a big change in pH. This is the most exciting thing I'm working on right now. I'm trying to synthesize. Right now, remember we have the global Vern 2 data product. We can plot the saturation state and pH for the global ocean very well. And then we have some people sending us emails saying that, oh, we have hatcheries in the west coast and the east coast. We are more interested in what's going on in our backyard, actually. So what we are trying to do is to synthesize all the carbonate data in North American coast. This include the west coast, east coast, Canadian coast, Gulf of Mexico, and Alaska. Here are the regular saturation data distribution. As you can see, they are very, very interesting. It's very low in the southeast. It's very high in the southeast and become systematically lower towards the north. It's very low in the west coast and very low in the Alaska. I want to use this opportunity to thank Libby and Dwight for their dedicated funding support for this project, and they have been emphasizing data management all the time. I really appreciate their support and support of this project. I want to thank Krisa. Krisa is now in IOS now. I want to thank her for the tremendous help she gave me to help get this project started. She was the leading PI on this project for the first funding cycle. I also want to thank her for the trust on me to let me carry this over. I want to thank Ross Parsons for helping me get the IT and archiving support from NCEI. This is critical. And thank John Ralph at the NCEI for all the IT support. All right, that's all. Thank you so much for your attention. I'll be happy to answer your questions.
Great, thank you so much for that. We do have a couple questions, which I can read aloud now. The first question is from Dwight. He said, with regards to the global pH distribution, have you considered the fact that pH is a log transformed quantity? And would it be more insightful to examine the distribution of hydrogen activity so that you don't mask the true dynamics on account of the log transformation?
Yeah, that's a very good point, Dwight. Yeah, it's probably a very good idea. I think I did some, I tried to calculate the concentration of hydrogen ions and do some plot. Distribution is similar, but it will definitely be different. Yeah, I will definitely get a different plot, just plot the concentration of hydrogen ions and share that with you. Maybe we can work together on this. Thank you, Dwight.
Okay. And right now it looks like we have one more question. If you have other questions, we still have plenty of time, so just type them in or you can raise your hand if you want to be unmuted. The question that we have right now is from Joseph Kunkel. It says, how does one predict the parameters of the winter months at the North Pole and South Pole when they are frozen over?
Oh yeah, that's a very good question. I basically got my results from the World Ocean Atlas. I don't think I can answer that question, but the good thing is that I did look at those results. They are very similar from different months in those regions. The change is very, very small because they are so cold all through the years. Yeah, but yeah, sorry, I don't know how they measure those temperatures when it's frozen.
All right. Another question from Joseph. What are the difficulties of predicting nearshore parameters?
I'm sorry, could you, what parameters?
What are the difficulties of predicting nearshore parameters?
Oh, the nearshore parameters. Yeah, right now we are still on the stage of just examining the data. We haven't done any projection yet, but the nearshore is so controlled by many different resources other than the intrusion of atmospheric CO2. It's going to, like a river. We have hypoxia and just too many things that could control them. Yeah, it's going to be much more difficult than the surface ocean, open ocean, because of the different controlling mechanisms. Yeah, it's also more challenging when it comes to quality control, actually, because in the open ocean we just rely on comparing the different cruises based on their measurements below 1,500 meters. But for the coast cruises, we cannot use that. We have to rely on something else to do our quality control. So it's very important that the first stage we probably should be focused on those data from those labs we trust.
Okay. It looks like that was the last question. I might just wait another few seconds. Again, if you have any burning questions, you can type them in now. We'll just wait a minute. Okay, it looks like we don't have any other questions coming in. So if you do think of something later, again, please feel free to use the information exchange. You can use that data management team to bring up questions or comments, or you can email Liqing directly, or you can email me, kelly@naricus.org, and I can pass on the question. But I think that's it for today. Thank you so much, Liqing, for the great presentation. And thank you everyone for joining.
Sure, thanks for the invitation.
Absolutely.
All right, bye guys.
Bye, thank you.